today we are going to see the problem power of 4, that you have been given a number n, then you have to check whether it is a power of 4 or not. If it is a power of 4, return true, else return false. So I would say, what would be the brute force solution? In that case, you can say you can start your counter from 0 to 31, and every time you multiply it by 4, and not 31 you don't need, because your number would be around 2 raised 31 minus 1, so that is 2 raised 31. So for 4 that would be around 15, so you can go till 15 and multiply it by 4, then you can check whether it is divisible by n or not. 4 16 64 and then 28, like that. And in the question you have been given that you don't need to use any for loop or recursion, then how we can do that? So let observe something. If that is 4 raised 0, that would be 1. If that is 4 raised 1, that would be 4. If it 4 raised 2, that would be 16. So 4 raised 2, basically that is 2 raised 4, and it is 2 raised 2, it is 2 raised 0. So you can see, if we talk about the binary representation of the number, that would be 1 1 and 0 and 0 1 0 4 0, so like that. So if I come with 4 raised 3, that would be 64, that would be 2 raised 6, 1 and 6 0. So the number of 0 here will always be even, that is one condition, and number of ones, that would be 1 always. So there are two conditions. Ones, number of 1, you can say number of ones would be 1, and number of zeros would be even. Now that is one condition. Now how can you verify this one? So you can see there is a bit trick to do that, that is an AND operation with n minus 1. If it is 0, then you can say there is only one number of n's, one number of ones. Okay, so that's how we can do that. And how we can do this part, we can see. I will start from the my number n, and I will try to shift it this side, and I will count zeros. I will count zeros, and if the total count is even, if total count is even, then I would say it is a true, else I will return false. Okay, now let me represent it in a binary form. That would be 1 and 1 0 1 0 1 0 1. Let's say this is a number, and this can be power of 4 only when the number of ones are 1. Okay, so I know that I have already applied condition on calculating the number of ones as well. Now I can pick this one, and I want to make sure that I have already 0 here in that problem. So how can I make sure? So I am picking the reverse of this string, inverse, you can say 0 1 0 1 0 and so on. And if I do the AND operation here, then what I will get? I will get 0, because in that position you should always have 0. And if you don't get here 0, you can say it is not power of 4. It is not power of 4. So you can see why I have written this one, because your number would be 1. Your number can be 1 0 and 0. Your number can be 1 0 and 0, like this one. So number can be in the form of this, and I am taking the inverse just to check that on the even position I have always 0. Okay, so this is the number. Now observe this number, that is 1010, and then 0 1 0 1 0 1. Okay, this is the You can see I will call it as a mask because I am doing the AND operation with n. So I want to represent this number in hexadecimal. How can I do that? I will pick these four. So you guys know that to convert the binary representation into hexadecimal, you pick in the group of four like this one. So you can see the pattern here. Every time you have 10 10 10 and 10 in binary form. So what is the value in decimal form? That would be 1 2 4 8 8 plus 2, that is 10, and 10 in base 10 would be a in base 16, that is hexadecimal. So you can see you have a here, a here, a here. So your mask would be, and guys, why I'm telling you to convert into hexadecimal, because you don't need to do any calculation this to convert this into decimal. You can convert this into decimal as well, but in code if you write in this form it will automatically consider it as this number. Okay, so that is our mask. So how many condition we have? We have one condition, number of one should be 1, so that will satisfy this condition. And another condition is n and mask should be 0, that will make sure that on the odd position we always have 0. Sorry, on the even position we have always 0, because you see we have seen the representation here. So you have one only on the odd position, 1 2 3 4 5, 1 2 3 1. So I want to make sure that on the even position I always have 0. And one more condition would be n should always be greater than 0, but because that would start from the 1 and then 4 and like that. So now let's see the code. It is pretty much straightforward, I think. So I have one mask and I am converting it into the decimal format. So instead of writing this much, I can replace this with my hexadecimal representation. That's why I was uh, explaining this hexadecimal format. So then we have one condition and we have another condition to check number of ones. Then we have this condition to check we have 0 at the even position. Let's try to submit that. Okay, so it got accepted. Yeah, I think that's all. So I think you can figure it out like why it is working. And I think you guys know like how hexadecimal representation and binary representation works. If you don't know, you can go with this solution. So you can construct the binary string, then convert into the decimal format. So that is also one way by which you can do. So yeah, that is the same runtime. Okay, yeah, that's all.